0 factorial, why does it equal 1? Okay, let's have a look. First, let's talk about how we compute factorials. So right here, we defined some number n factorial to be, you start with n, and then you go to the next number, and you multiply them, and you continue, so the next one is n minus 2, so on, so on, so on, up to we get to 1, and then we are done. So for example, if you have 4 factorial, plugging 4 into here, we get 4, times 4 minus 1 is 3, times 4 minus 2 is 2, and then once you reach 1, you are done. So 4, 3, 2, 1, multiply them, we get 24. Yes. Now, you might be thinking, how about let's plug in 0 into this formula, and that will be 0 factorial is equal to 0 times negative 1 times negative 2, and so on, so on, so on. But now we have two troubles. The first one is that, where are we going to stop? Because I can never reach 1, the numbers are getting negative, all that stuff. Okay, the second thing is that, maybe I don't even have to worry about that because I have 0 times all this already. 0 times any number is just equal to 0, so the answer shall be equal to 0, right? No, this is not how we are going to work out 0 factorial, because we define this formula to be only good for positive whole numbers n, meaning n is equal 1, 2, 3, so on, so on, so on. We are not allowed to plug in 0 into this formula and work out. It doesn't even make sense in the first place. So now, how do we get 0 factorial? Let's have a look at this and then continue. If we put down 3 factorial, that's 3 times 2 times 1, 6. 2 factorial, 2 times 1, 2. 1 factorial, 1. Now, what's the pattern that I'm doing on the left-hand side? 4 factorial, 3 factorial, 2 factorial, 1 factorial. You know what's coming? 0 factorial. Okay. Let's look at the results on the right-hand side. Don't worry about anything like that anymore. 24, 6, 2, 1. What's the pattern? We can look at this as from 24 divided by 4 to get 6. But we don't divide this by 4 anymore. Instead, we take 6 divided by 3 to get to 2. And then we take 2, we can divide it by 2. We do have a pattern of the numbers that we are dividing, 4, 3, 2. The next one is we are going to be dividing by 1. Take 1, divided by 1. 1 divided by 1 is 1. As you can see, the left-hand side is 0 factorial, the right-hand side is 1. This is one reason why we define 0 factorial to be 1. I really like this explanation because we can actually continue. If you continue, you will be talking about negative 1 factorial. We do have negative numbers, but let's see though. Divided by 4, 3, 2, 1, what's next though? That will be dividing by 0, isn't it? However, what is 1 divided by 0? Uh-oh, we have some trouble now. We cannot divide it by 0. The response for this part is undefined, meaning there's no answer for that. That's something that we cannot do in math. And here we're just talking about from an arithmetic point of view. We are not talking about calculus or whatnot. No limits, none of that. Therefore, you can see negative 1 factorial is undefined. However, though, do not do negative 2 factorial and say take undefined and then divide it by negative 1 and say negative 2 factorial is equal to negative undefined. Don't do that. We just don't have negative whole number factorial if you stick with arithmetic only. Yes, some people might say negative 1 factorial is equal to infinity and then negative 2 factorial is equal to 0 and so on. But that will be maybe another day. So the purpose of using the factorial is to help us compute the number of ways to arrange certain amount of items. For example, I want to see how many ways that we can arrange a total of 4 different items. And I'm just going to call them A, B, C, D. They can be like 4 different books for 4 different people and so on. And now let's think about it. A, B, C, D. If I want to arrange them, I can put A, B going first, but I can switch C and D, and then I can have A, but B has changed. I can say C and then B, B, and then A, C, and switch then D, B, and then A, and then D, B, C, A, B, C, D. And of course, we have a lot more ways, right? But notice that there's a nice pattern that's going on. And let's see how we can actually just figure it out without list them all out. So far, we have 6 ways to arrange A, B, C, D, where A is going first. But if you think about it, next, I could say start with the same group, but B going first, and then C going first, and then D going first. We will have 4 groups of this kind of things. So 4 times 6, that will be 24. However, if you want to just go with computations, you can think about it. If we have A, B, C, D, how many ways can we select an item to be put into the first spot? 4. Maybe A, maybe B, maybe C or D. And then once we use one of them, then we only have 3 choices left for the next one. Similarly, 2 more choices, and then lastly, the only choice. All we have to do is multiply them, and you see that is precisely 4 factorial being equal to 24. Just like that. Now, we are trying to arrange 0 items. And this is more like almost like a philosophy kind of question, right? Firstly, what item are we talking about? I don't have any item for you to arrange. However, can we still do it? Yes. Have a look. If you have nothing on the board right now, the only thing that you are going to see, the only configuration that you are going to have is this thing. It's just like a blank space, right? So you still have one way to arrange nothing, and that tells you 0 factorial is equal to that one way, which is the blank space. As opposed to earlier, when you have 4 different items, right here we have 6 different configurations already, where A is going first, and then we have B going first, C going first, and D going first, and all that, a total of 24 ways. But right here, you don't have anything on the board. That's the only thing that you're going to see. Therefore, 0 factorial is equal to 1. The only thing that you have to do is to do nothing at all. That's it.